Hi, my name is Norman Meir, and welcome to this session on basic concepts of electrostatic discharge, or ESD. I am a master instructor for J Standard, which deals with process control, 610, which deals with specifications on how everything should be placed on an electronic circuit board, 771121, rework and repair, 620, wires, cables, and harnesses, and 6012, which is board fabrication. What we're going to be talking about here again is on ESD and its basic concepts and what we need to know to protect our workspaces. As technology has progressed in our world, parts have gotten smaller and smaller because we want our equipment to do so much more. Look at the original cell phones. They were called bricks, very large items. Now look at them, they're very small and we can do a lot more with them. Well, in order for us to do all this, we had to go from through-hole to surface mount. So things have gotten smaller and smaller, and that means more sensitive to static electricity or any other unwanted electrical energy. So we're going to talk about this, and I hope you enjoy this. Says we're going to talk about here is the causes of ESD, strategies to minimize the ESD, operating procedures to minimize ESD in our workspace. As a student, you'll be able to define ESD and explain its causes. We'll understand how products they handle can be damaged by ESD in our workspaces, and we'll understand the consequences of not controlling ESD in our workspaces. So this is what you're going to get out of the next 30 minutes to 45 minutes. We're going to be talking about all of this information and educate you better, especially in your work environments, whether it's a big facility like ours or even larger than ours, or just 2 or 3 people working in one area, especially when you're working on cell phones, because that's popping up everywhere and they're not aware of static electricity, and we're trying to get you educated on that knowledge. So what is ESD? That's the first thing we got to define. It's electrostatic discharge is the sudden discharge of static electricity energy between 2 objects. The key word here was sudden, but we can also talk about rapid. Either or. It happens so fast that it's already done. When you go and walk across that carpet and grab that doorknob, you're discharging immediately. Okay? It happens. Look at lightning. Another thing. Happens so quick you don't even know it. Sometimes. You hear the noise and it's like you start looking for the lightning. It has already occurred. At nighttime, it's more visible than it is before. So we're going to be talking about these and the cause and effects. So, causes. First one. 2 objects rubbing against each other. Friction. Your hands rubbing together like this can cause static electricity. Remember when you were a child, you grabbed that balloon, you put it on your head and you rubbed it really hard and you put it up on the ceiling and it stuck? That was the charges connecting to each other. You got positive and negative charges, okay? So it was connecting to itself. But if you noticed, your hair started going up also. The other one is 2 objects separating. In today's world, when we buy magazines, it's more prevalent there. It's because the pages are stuck together. You get a magazine, it's about this thick, but as time progresses and you start looking through it, it gets a lot thicker, almost double in size. That's because these pages are stuck together with static electricity. And because it's going through that printing press so fast, and then you're separating, so you're creating that static electricity. And here's another example of it here, is showing of you separating tape. It's a pretty neat little thing to see. Okay, what happens here is many charges. You got a high potential and you got a low potential. So what is happening is they're trying to balance each other. Okay, so you got all this energy up here and very little down here. So what it's trying to do is go to equal. Just imagine, like in Hoover Dam. You've got a dam here, very large dam, right? Then right behind me is all this water. And then you look on the other side, there's just a trickle going down through there. Well, if I open up them flood dams, what happens? This water comes down, this water comes up, doesn't it? Well, that's what you're doing here. So you've got to be very careful about these high potentials and low potentials. You want to keep everything at an even keel, okay? It says the smallest electrostatic discharge a human body can feel is about 2,000 volts. Just imagine that. You are generating minimum, where you can feel and hear it, is 2,000 volts. Very, very little, isn't it? You don't even realize that. But like it says here, we can generate over 25,000 volts. 25. Well, we got electronics and components that operate less than 4 volts. And you're hitting it with 2,000 volts or voltage that you're not even aware of. It can cause issues in the electronic circuits. So you got to be very careful. You got to be very cautious. You got to wear a lot of, not a lot, you got to wear a smock like I am, maybe a wrist strap, some heel straps, something to protect that environment. And we're going to talk about some more of these things as we go along also. So here is a nice example of electrostatic discharges as it passes through a circuit. Look at it, it's eroded right here. Well, what happened? That energy came through there. And it doesn't have to blow the circuit completely up. It can degrade it. In other words, cause some damage that we call latent damage. It doesn't happen right here and now that it's bad, but as time progresses, that energy keeps hitting it, it keeps eroding at it, and then guess what? One day your cell phone doesn't work, your game system doesn't work, your television doesn't work. These are the things that can occur from just this little bit of damage. Just think of this as water's rushing through a little area. And if it keeps rushing through it, it stays the same. But if I add more energy to it, it starts eroding, the sides start caving in, doesn't it? Well, that's what happens to static electricity. It's that same concept. So consequences of not taking care of this is waste. What do you mean by waste? Look at it. Higher product cost? Unhappy customers? Well, how do I get all this? It's very simple. One, you didn't use your ESD strap right. You didn't do something right. You grabbed a hold of that circuit board coming off the line and you caused damage. Well, guess what? You've got to rebuild that board now or fix it. So new board, new parts, well, that's man hours, that's equipment cost, that's energy cost. Higher product cost now because you're not paying attention. Oh, I'm sorry, you didn't get your product out on time because you had to rework it or fix it. So now your customer's not happy. Why? Because they didn't get their product on time. We all know this. If we have our cars worked on or anything like that, we expect it back in a timely manner. And if we don't, what happens? We get irritated with that customer, don't we? Or how about at a restaurant when we order a food and it takes forever to get there and you sit there and wait and your conversation and it's coming to a lull, well, your food finally arrives. It irritates you because it didn't get there on time. So that's what we're looking for. So, non-conductive materials, data diskettes, vinyl binders, safety glasses. We have to have them in our workspaces a lot of times, but make sure that you wear them properly and that you wear your wrist straps and in a great environment to work in. Plastic pens. How about highlighters? Post-it notes. These are a lot of things that we see in our environment and we got to be careful with. Oh, scissors. We have to cut things once in a while. So we got to be careful with that also. So this is what we're talking about. All these items, they're insulators. Oh, we got to have our morning cup of coffee, you know? So you got to watch out for these in your environment because they can generate, but they store static electricity too. So you got to be careful with that. Conductive materials. This is all your metal products, right? You got tweezers, you got pliers in your work environment, Part of your ballpoint pen is metal. How about the conductors on the circuit board are metal? Nuts, bolts, and screws laying around are all metal. What happens here is the energy passes through it. It doesn't slow down. It keeps on going. It travels on. And that's what we have there. That is conductive materials. Partial conductors. Did you realize that you are a partial conductor? You can store energy, but it dissipates out too. You stand in water and grab a hold of something electrical. See if it doesn't pass through you to ground. That's going to be a conductor, right? You've grabbed at Christmas time or any other time, grabbing a plug out of an outlet and slip, and you grab a hold of the two ends while they're still in, you get shocked, don't you? Okay, but you can store that energy too. Charge field. What do we do here? What do we mean charge fields? How can we create a charge? Very simple. Is how do we avoid loose-fitting clothing? What do you mean? Oh, remember that rubbing, that movement that goes around? Okay, that can cause static electricity or generate it. Keep ESD-sensitive devices at least 12 inches away from your clothing. Why? Because remember, this moves around and stuff, but I've got a jacket on instead. Wear materials made of cotton. But remember, if you're wearing cotton, a lot of times people iron them or have them starched up. Well, that defeats the purpose of the cotton knot in creating static electricity. When I was in the Marine Corps, that was one thing. You know, you had to be pressed up really nice every day. So we had to starch our uniforms so they looked nice and crisp. Well, guess what? We were defeating the purpose of the ESD program because our clothing is made of cotton, so it can breathe a lot easier. But that's what we have to do. Wear static dissipative shoes or heel straps when you're walking around in your workspace. We'll show you these later in the video. Wear wrist straps when seated. No unauthorized objects or materials inside the static-free boundary. Remember what we showed you. If they don't need to be in there, if you don't need that coffee cup in there, don't bring it in there. One of the biggest violators I see now is people with cell phones. You've become tech zombies. You have to keep in contact with somebody constantly. Why? Who knows? It's just your mental thought now. That's what you have to do. Okay? iPods. I gotta listen to my music. Okay? Well, what's that case made out of? Plastics. Okay? Can it store static electricity? Yes. So you gotta be careful in your workspace again. Eliminate unnecessary non-conductive materials inside the static-free boundaries. If they don't need to be there, don't bring them in. Bottom line. Avoid friction-producing activities. Brushing your hair, wiping yourself off, stuff of this nature. These can cause static electricity. So let's try to prevent them from our work areas. Humidity in ESD. 30 and 70%. We've got to watch out for these. In accordance with J Standard 001, you want to maintain between 30 and 70% in your workspace. It's in Section 4 of the standard itself. Okay, this is something I didn't make up. They've got enough case studies to prove this. Anything below 30% in some companies, it's complete work stoppage. Okay, because what happens is humidity increases as static electricity increases as humidity decreases. As humidity increases, static electricity decreases. Very simple. So you've got to start monitoring it below 30% because components become more sensitive because there's less moisture in the environment. Now when it's above 70%, you've got to look at too is moisture sensitive devices. So, a lot of the components that are made of plastics are very sensitive to moisture. Prime example in our surface mount is one of the big ones is the chip capacitors. Moisture gets inside that ceramic little guy, and when you hit it with an iron, and as small as it is, that evaporates. In other words, it turns into a vapor. That expands, right? It can crack or fracture the inner layers, and you're not even aware of it. You replaced a part. That wasn't even what caused it. It was you hitting that iron with it, and it happens just like that. So be very, very careful. Okay, here's some of the examples. Look at these. Worker at the bench, walking over vinyl. Look at this vinyl flooring. 12,000 volts. That's a lot of voltage coming across there. But as humidity increases to 65 to 90%, look at it. dropped to 250. So you got to watch that. Humidity in our workspace. How can we help prevent some of this in our workspace? Static-free solutions. It comes in a lotion. You can actually get it as a towelette, and you can wipe everything down. A lot of people do it on a daily basis. Some companies do it 2 or 3 times a week. It depends on what you want. Or they can just alleviate all that and use these things called air ionizers. And what this does, and the good ones you want, that produces positive and negative charges constantly going out. So what are you doing? There can't be a high potential, there can't be a low potential, it's all got to be the same, because you're constantly putting the same amount out there. So it's keeping everything even now, isn't it? And air ionizers are great. A lot of companies do use them. Draining off the charge. How can we do this? Does this system work well that we have been talking about that we're going to talk about? Wrist straps, ESD mats, or heel straps. Will this work well? Let me see. Works for conductors. Yes, because you're keeping it at ground potential of 0. So it's a straight shot to it. Partial conductors. If I put a wrist strap on, like I'm wearing right now, that's part of my smock. Okay, yes, it works out. Non-conductors, air ionizers work well with it, but if I just ground it, it could actually store it, okay, for a little bit of time, especially like on our styrofoam cups and stuff like that. It's held in check. Draining off that charge. Okay, how do we do that? First off, one of the easy ways, I don't have to own a smock. I can wear a wrist strap, just like this, and I put it on. And it's snapped into place right here. And this end, believe it or not, would be attached to a mat. This mat is something like this. It's an ESD safe mat. It's got a mesh barrier in it. It's all to ground. It's got a 1 mega ohm resistor in line with it. And all I would do now is just come over here and snap it into place, something like that. And then now I keep all my equipment and materials on this ESD safe mat. And then I don't have any issues whatsoever, or should not have. Okay? That's another way to do it. Nice dissipating mats, wrist straps. But if I don't want to wear a wrist strap, because if you notice, this gets in the way a lot of times. So companies will buy smocks like this one that has it built into it. So all I have to do now is just snap it right here, right there, and then I plug it in. Now, I can do whatever I want. I don't have to worry about anything whatsoever, because I'm at a ground potential of 0. I can keep working and doing what I want. Like I said, it has a 1 mega ohm resistor. It actually allows you to dissipate it slowly, not rapidly. How often do we test it? It depends on your company's requirements. Minimum is usually once a day. And all you do is just plug it into a system and you test it. No big deal with that. I go to companies, prime example, I was in Penang, Malaysia teaching several years ago. And to get in, for their doors to open, you plug the wrist strap into the tester, and then if everything's right, the doors open. Well, believe it or not, mine didn't work. It's like, you rotate your wrist around and stuff, and that could be intermittent issues, but it still wasn't working. So what I had to do was take this lotion that they have, ESD safe lotion, like a hand lotion type material, and I wiped it all over my arms and my hands, and I did it again. Well, guess what? The doors opened for me. So that's what you got to look for, is stuff of that nature. And not a lot of companies. There is companies out there. To get into work, you have to do this. Get into that workspace like I just talked about, you have to be ESD safe. So these are one of their fail-safe ways to do it. Okay? Wiggle the wrist strap when testing. Again, like I said, it could be intermittent. The heel straps. These are great little items of interest. Okay? They're nice. Okay? Got a little Velcro, got a little tap. And this goes around the foot. Your shoe fits right into here, just like so. Then you've got this. This goes in between your sock and your shoe on the inside. So you push this all underneath it. Moisture and everything will create a path. and then you put this down there. Now you keep, this is hitting the floor all the time, okay, as you walk. Okay, very simple. Now, one of the things about these that I see people doing a lot of times is they walk outside, they take their coffee breaks, they take their cigarette breaks, or like today, it's very nice out, they want to take a little bit of a walk because it's getting off the wintertime, spring is here, feels so nice out there. So, what do? They get dirt and contamination on here. So now, when you're walking on that ESD safe flooring, guess what? It doesn't work. It's not creating a path anymore. So that's why you should never wear these outside or off an ESD safe floor. Now you can also, instead, if you don't want to buy these and use these, you can also have ESD safe shoes. They are available in the market. Okay? Says the smock is the next thing, buttoned up completely. Mine is all the way buttoned up, as you can tell. They do come up higher if you want to buy that kind with the nice little collars and everything like that. It says not rolled up. You don't want them all the way up in here or over the top of your clothing because it's not protecting anything. It says contact skin or ground strap. That's what you want it to do. Static dissipated protective materials. The surfaces will absorb the discharge at a rate which will not harm it. In other words, it discharges slowly. You don't want it to happen too fast. And that's what we're talking about. So we've done that part, no problems whatsoever. Now, we've got to carry and transport these things. Okay? We have totes that we can use. Make sure they're completely closed and everything is inside of it. They're nice, clean, and not dirty. Because dirt, if you get this dirty and there's contamination on here, it could actually create a path. And guess what? Static electricity can get inside and cause damage. So we want to be very careful with that. Okay? Bags. That's what we're talking about too. So we got these nice ESD safe bags. How do we know that? It's very simple. Our bag will indicate with some type of marking on it. For this one here, and I'll bring it up closer for you so you can see it, as you can see right here that it says attention static sensitive device. See, it's got the little halo around it. Means that it's protecting everything inside of it. Okay? Now, when you're transporting anything around the area, you should always put it inside the bag. Okay? Yeah, this is a little bit larger bag than what you would probably normally use. But you can put it inside of there, fold it up, make sure it's completely secured, and now it can be transported anywhere you want, inside the facility or out to your customer. It does not matter. Okay? What a lot of them will do, this is a static bag. Now you have your anti-static bags. It's like this pink poly stuff. Okay? It's used for cushioning and protection. Now this will not generate static electricity, but electricity will be allowed to pass through it. So a lot of times they'll put that in there, they'll seal it up, and then they will put it inside of the bag itself, and then seal that up. And now it can go off to the customer, just like that. Some of the handling and transportation rules. It says here, first off, keep the device on a static dissipative surface. Keep it on that mat until you're ready to put it inside of that bag. Makes it very easy. Keep all leads on there too. Remember, it says never slide an ESD sensitive device over any surface. Remember, sliding causes static electricity, and we don't want to cause that. Never handle the ICs by its leads. Well, if it's done, you want to keep it on that mat. Remember, oils and acids from your neck, anywhere else, couldn't cause static electricity. Not. What it will do, though, it will contaminate the leads and prevent a good quality solder joint. A lot of people say, well, I rub my neck and stuff like that, and that'll cause static electricity. That's not true. It's the oils and acids on the back of your neck that causes the issue. Okay? Avoid rapid friction producing activities. In other words, you don't need to comb your hair, dust yourself off or anything in your workspace. You can walk away from that. Remember, if you're brushing your hair because you want somebody to notice you, they've already noticed you in the workspace. They still notice you in the break area the same way. Okay, minimize handling ESD sensitive devices. If you don't need to touch it, leave it alone. Always use clean static dissipative containers. We explained to you earlier why. Always make sure the device is completely inside the closed container. Because if it's not protecting anything whatsoever. Come on, think about this. Let's grab that board real quick. We want to take it down to Billy, right down the thing. I got a component that needs replaced. So what do? You do this. I call it the Taco Bell carry, because you wrap it around it like this. This is not being protected whatsoever, and you go down there. So anything that's ESD sensitive on there could be walking past something that's plastic, it's rubber, it's a non-conductor. Going to discharge into the component. So don't do it like this. Again, put it inside the bag to transport it from point A to point B. Okay? Never seal an ESD bag by stapling it closed. You're poking holes in it. Now is it protecting anything? That's like trying to fill a bucket up with full of water and it's got a lot of holes in it. Is it going to keep? It's going to take you a lot longer, and it might not ever fill up. So think of it that way. Never leave a device on top of a static dissipative container. Again, put it inside. Always use only ESD sensitive approved tapes. I have seen so much of this. I've seen people using regular Scotch tape. I've seen people putting Post-it notes on top of circuit boards because they want to make sure that we know which part has to be replaced. Well, guess what? Static electricity causes issues. Never place static plastic pocket travelers on or near a container. Remember, it's a non-conductor, it's an insulator. It is storing static electricity. So keep them out of the workspace. Always use cars designed for ESD sensitive devices, because some people use like Rubbermates and stuff of that nature, and they've got all the things on. Well, guess what? That's got wheels that are turning, isn't it? It's causing static electricity. The static electricity is coming up them legs, going to that tabletop. Guess where your board is? On top of that tabletop. So it's getting all sorts of electrical day going on. So always check to see that the card is grounded and that all shelves are in complete contact with the frame. And then that is touching the floor. That way everything is ESD safe. All ground potential of 0 as you're transporting it. Well, I hope you've enjoyed this. And it says here, you got any questions? If you have any questions, contact us here at BEST. My name is Norman Meir, and like I said, I work for BEST Incorporated as a master instructor. We can answer your questions, and if I'm not here, there's several other people. Another one would be James Barnhart. He is another master instructor. Francisco, he's another one of our instructors here. We got a lot of people in the back that are supervisors, could discuss this with you about ESD programs. So I hope you've enjoyed the last 30 minutes of our program. And again, be ESD safe. And thank you.